So we're going from proving triangles to congruent to parts congruent. What you're going to need to do for these is you're going to have to first prove a pair of triangles are congruent, and then you can say the parts are congruent. I'm going to talk about what you're going to say with that. So you're given AB, so I'm going to put, I know AB is parallel to DE. That's given. I know BC is congruent to DC. That's also given. It's marked in my diagram. I like a little bit more color. We've done this one before. First thing I want to do is I want to prove these triangles congruent. So I know angle B is congruent to angle D from what we did last class. So that's going to be alternate interior angles theorem. And something I should have remarked about from the last videos is there's more than one way to prove congruence for this one. This one right here, you have your alternate interior angles, but you also know, so you could say A is congruent to E and that would be fine, but some of you might want to say the vertical angles are congruent because maybe that's something that you see. So I also know angle ACB must be congruent to angle, must be congruent to angle ECD. And that's going to be because of vertical angles theorem. And write THM for theorem. Regardless of how you do it, you now have three pieces of information. For me, this side is included, so I know that triangle, and I'm going to be really careful labeling it, is going to be triangle ABC is congruent to. So angle A would have to be, don't want to do that. Angle A would have to be congruent to angle E, so this would be triangle E. Angle B was congruent to D, so I'm going to do EDC. And how did I know? That's going to be by angle, side, angle. Once I know that the triangles are congruent, I know, and this is actually from the beginning when we started this unit, that if two triangles are congruent, all of their parts are congruent. So I know that if those triangles are congruent, then AC would have to be congruent to EC. And the reasoning is CPCTC. I know that corresponding parts of congruent triangles are congruent. That's what that means, that if the triangles are congruent, the parts have to be congruent. So that's your ultimate goal, and I have a whole bunch of proofs because these can I just wanted to do some dicey ones. That's what you do. You prove the triangles are congruent, then you can prove the parts are congruent or some other things. So number 2 here, you're given AC is congruent to EC. So I mark it in my diagram. I write it down. AC is congruent to EC. Always write your givens. Don't skip that step. Okay. You're also given BC is congruent to CD. Okay. That's also given to you. That's all information I'm given, but again, I see here that I have my vertical angles. And so I know never say angle C is congruent to angle C, okay, because there are 4 angles there, okay? So I'm going to call this angle ACB, okay, the vertex is always in the middle, has to be congruent to angle ECD by vertical angles theorem. And if that's true, now we have enough information. I know triangle, and if I call it ABC, well, and we can mark this in the diagram. Well, I know angle A, that's not what I wanted. I know angle A had to be congruent to angle E, and angle B had to be congruent to angle D, okay? So I know triangle ABC is congruent to EDC. And always put the triangle there. And how do I know this is going to be side, angle, side congruence? Okay, once you're done there, it's very easy. I know that those triangles are congruent, so angle B has to be congruent to angle D because corresponding parts of congruent triangles have to be congruent. In other words, the triangles are congruent, the parts have to be congruent. Okay. All right. So something similar. So we have AC bisects angle DAB. Okay, that's given. And I know AB is congruent to AD. That is also given to you. All right. I go to the bisect thing because I realize that if if AC bisects and this whole angle, this angle here, then I know this part has to be congruent to this part. So I know angle BAC must be congruent to angle DAC. And the reason is definition of bisect. Okay. Now we have two things. We need a third thing. I always say look for reflexive property and vertical angles. There's no vertical angles here, but I do know that AC is congruent to AC. Okay, that's going to be reflexive property. Okay, and so now I know, well, triangle, and I'm going to say ABC is congruent to triangle. Just make sure your letters in the right order, ADC. So again, A has to be in place of A, B has to be in place of D, C has to be in place of C. And that's going to be by side, angle, side congruence. Then I know for sure angle B would have to be congruent to angle D because corresponding parts of congruent triangles are congruent. Okay. Just three more. It's not that bad. Actually, we're going to skip number 4. I don't think 4 is necessary. I'm going to take that away from the notes just because it's just repetitive. We kind of been doing the same thing over and over again. You know, midpoint divides a segment into two congruent parts. So, you know what? I will go over this one because this one's kind of interesting. Okay, so you're given C is the midpoint of AE and BD. This one would be good, I guess, if you wanted to try it on your own. So this is given to you. If C is the midpoint of AE, okay, then I know AC must be congruent to CE. That's definition of a midpoint. Okay, and you also know if it's the midpoint of BD, because now it's both, I know BC is congruent to CD. This is also definition of midpoint. Okay, I have two things. Again, we look and see, oh, we have vertical angles, so I know angle BCA must be congruent to angle DCE. Okay, vertical angles theorem. Now I have three things. I can say triangle ABC is congruent to triangle EDC. Okay, and that's going to be by side angle side congruence. And then we have enough information. We know AB is going to be congruent to DE, and that's because corresponding parts of congruent triangles are congruent. Okay, just two more. I just want you guys to have this for reference. So this is a little bit different. I like these ones. These kind of interest me. So we'll go through our givens, and then we'll talk about our goal. Okay, because I'll show you what's a little bit different with this. So HG bisects angle JGK, and I know JG is congruent to KG. So I know, even without looking at my proof, maybe I'm just going to ignore this because this might be confusing to you for a minute. I know that I need to prove that these triangles are congruent because I just feel like that's somehow going to help me. So I have my two givens. I know JG is congruent to KG. I'm given that HG bisects angle JGK. So that means that angle 1 must be congruent to angle 2. That was given definition of bisect. So I know that those are congruent. And then I'm looking for my third thing. I know GH is congruent to GH. And that's reflexive property. Okay. So now I have enough information to say that triangle JGH is congruent to triangle KGH. Okay, by side, angle, side congruence. That said, now I know my triangles are congruent. Well, now I want to think about how I'm going to prove that H is the midpoint. Okay, so if H was the midpoint, I want you to work backwards from this because that's going to be your last step. I know the very last thing I'm going to say is H is the midpoint of JK. So what would show that? Well, what do we know about midpoints? Well, if we look back up here, we know that a midpoint divides a segment into two congruent parts. And so if I can show those two parts are congruent, I can say that it's a midpoint. Well, I know that these two triangles are congruent, so I know for sure, that, oh, no, wrong color. Let's go with yellow. I know that JH has to be congruent to HK. Because I know those triangles are congruent. So I know because corresponding parts of congruent triangles are congruent. If those two parts are congruent, then H has to be a midpoint. Why does H have to be a midpoint? Well, that's because it's definition of a midpoint. Okay? I showed that, well, if the two parts are congruent, then H has to be the midpoint of that. So that's what I had to do first. I had to show that the parts were congruent, so then I could say, well, that's definitely a midpoint because it splits it into two congruent parts. All right, last one. So we have AY is congruent to BY. That's given. Okay. So AY is congruent to BY. We also know AX is perpendicular to AY, also given. So AX and AY. And we also know that BX is perpendicular to BY. Now this is going to be significant because now I know I'm dealing with right triangles, and we really haven't done too much with proving right triangles congruent to each other. But for this right here, alrighty, I'm looking at this and I'm looking for hypotenuse leg theorem. So when I'm given perpendicular, I start looking like, so my question is this going to be hypotenuse leg? Well, I have a leg, so this right here is a leg. And so I'm looking at this diagram and I'm like, oh, yeah, because XY is the hypotenuse. So do we have a hypotenuse being equal to hypotenuse? Well, yeah, I know that XY must be congruent to XY by reflexive property. And so, or of congruence, or just reflexive property, you can just write reflexive property. So I know that triangle AXY must be congruent to triangle BXY by hypotenuse leg theorem. Okay, and once I know that those two triangles are congruent, well, now I have to start thinking about how I'm going to prove the rest of this. So I know the very last line. I'm just going to write that, and I'm going to leave a little bit of space. I know that XY bisects angle AXB. Okay, and I don't have my reasoning for that. I'm just going to kind of leave that blank. So what I have to think about is, what was the line before? What would I have to show to say that it's bisected? And so I look at angle AXB, which is this angle right here, and I'm like, well, if that's bisected, then angle 1 would have to be congruent to angle 2. I know angle 1 must be congruent to angle 2. And that's because, well, no, I know that that's what I would have to use to prove that. Sorry, I got thrown off by the little comments at the top. So, do I know that angle 1 is congruent to angle 2? Well, yeah, they're parts. Since I know that these triangles are congruent, the parts have to be congruent. So I know angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent. And so now I know that those two angles, those two parts are congruent. So xy has to be the bisector of AXB. And why is that? Because that's going to be the definition of bisect. I've shown that the two parts are congruent, so it has to be a bisector. And so that's my notes. I know they're a little long on the more complicated ones.